Tillage is one of agriculture's oldest operations. It prepares seedbeds, controls weeds, and mixes residues and amendments into the soil. Within the broad spectrum of tillage practices, deep plowing, often called deep tillage, subsoiling, deep ripping, or deep plowing, specifically refers to mechanical soil disturbance that extends well below the depth of ordinary plowing, typically 30 to 60 centimeters, and in some remedial contexts even deeper. Abdallah Hussein et al. 2019, Huang et al. 2023. Farmers employ deep plowing to address subsoil constraints such as hard pans and compaction layers that limit root growth, water infiltration, and plant access to subsoil nutrients and water reserves. Yet deep plowing has a complex and variable record. Meta-analyses and field experiments report both yield increases and yield depressions depending on context. Schneider et al. 2017, Huang et al. 2023. This essay adopts an applied agricultural perspective. It explains the science behind deep plowing, describes common techniques and equipment, synthesizes the empirical evidence on agronomic and environmental outcomes, discusses economic and practical considerations, and proposes integrative, sustainability-minded recommendations for when and how to use deep plowing effectively. The analysis relies on peer-reviewed studies, meta-analyses, and institutional reports to ground recommendations in the best currently available evidence. Schneider et al. 2017, Alcantara et al. 2016, Abdallah Hussein et al. 2019, Peralta et al. 2021, USDA ERS 2018.
The science of soil constraints, compaction, hardpans, and subsoil resources. To understand why farmers sometimes plow deeply, it is necessary first to understand subsoil constraints and the distribution of soil resources. Soil compaction and hardpans. Soil compaction is an increase in bulk density and decrease in porosity caused by external pressure, e.g., heavy machinery, livestock trampling, or by natural processes such as ill-structured clay layers. When compaction concentrates in a distinct continuous layer below the tilled horizon, it forms a hardpan or plowpan that restricts root penetration and water movement. Soan et al. As summarized in meta-analysis Schneider et al. 2017. Compacted subsoil reduces infiltration and hydraulic conductivity, increases runoff, and limits the vertical exploration of roots, which can cause drought vulnerability and poor nutrient uptake. Peralta et al. 2021. Subsoil as a reservoir of water and nutrients. The subsoil below the typical 0.25 cm topsoil often contains substantial pool of water and slowly available nutrients, PK micronutrients, that are not accessible to crops when roots remain shallow. Schneider et al. 2017. In dry spells, the capacity of deep roots to exploit subsoil moisture can be the difference between crop failure and reasonable yields. Similarly, deep incorporation or exposure of subsoil nutrient pools via mechanical mixing can improve plant availability under nutrient-limited conditions. Schneider et al. 2017. Alcantara et al. 2016. Biological and physical functions of soil structure. Soil structure, the arrangement of aggregates and pores, controls aeration, water retention, and the habitat for soil biota. Disturbances that alter the structure modify the soil's hydrologic response and biogeochemical behavior. Deep plowing changes the vertical arrangement of organic matter and aggregates, translocating surface organic carbon into the subsoil and vice versa. These changes can have long-term effects on soil organic carbon, SOCC, stabilization, and mineralization. Alcantara et al. 2016.